Drylet, and I'm going to read a little bit because I don't want to misstate their accomplishments, which are pretty impressive. So last year they were WEFTEC Technology of the Year winners. Pretty impressive for something as large as this exhibition. And this year, Frost & Sullivan's Technology Innovation Award in biological engineering. So another impressive accomplishment. He's going to tell you about the biocatalysts that you make and how you apply them and what the benefits are. And I know you're a great storyteller, so I'll let you spin in your art.
Okay, thank you. Good afternoon, everyone, and thank you for stopping by our booth. We're Drylet, and what we do is we have a biocatalyst that is used to enhance any type of bioremediation. In wastewater treatment, we're fundamentally using microbes to do the treatment. But the reality is, if you think about a wastewater process, there are about 7 to 8 different factors that determine the microbes that emerge. It's things like the type of food that you have. By definition, in wastewater, we don't control the food. The food is waste. If it was a brewery, we would go buy the hops. We would choose the food that the bugs would have. In a wastewater plant, we can't choose the food. The food's the food. So things like temperature, pH, alkalinity, redox conditions, SRT, HRT, all those things affect the types of microbes that emerge. Most times in a lot of our plants, we're using things like HRT and SRT to kind of play around with the type of microbes we have. So if we want to do nitrification, we would push out the SRT, so we would have nitrifiers to do the treatment. Sometimes you see bulking conditions in a plant. Sometimes you see filaments. All that tells us that there are times when we see microbes emerge that might not be optimal for what we're trying to do in a plant. What we do in Drylet is we do bioremediation. And what we're doing in bioremediation is you're simply microbial supplementation. And all you're doing in microbial supplementation is you are bringing in beneficial microbes into a plant. You're making sure that no matter what happens, you have the type of microbes that you need to provide you with things like improved settling, odor reduction, sludge, biosolids reduction. That's a big thing in any plant. Increased biogas generation, and things like enhanced clarifier capacity if you have good settling within clarifiers. So what we basically do is our product integrates material science and microbiology. So how do we do that? What I have in my hands, this is a dry, free-flowing powder. It's a porous media, and what our technology allows us to do is to embed within this porous media microbes. So there's a consortium of microbes that we're able to embed. Those microbes have, again, all these beneficial properties we've talked about. Allows you to reduce biosolids generation. Before you leave, I'll encourage you to pick some of the materials. We have plants where we've been able to help them reduce as much as 40 to, in this particular case for this plant, as much as 78% of the solids that were being generated at the plant. So just allows you to have significant, the capacity to have control over things like that. And so basically what we do is we embed the microbes inside the porous media. This media, a pound of this material, has a surface area of about 700,000 square feet. This convention center is 1.5 million square feet, so 2 pounds. These 2 pounds, each one is a pound. 2 pounds of our material has as much surface area as the entire convention center. Why is surface area important? The way bugs get food is by first absorbing the food. So all your soluble BOD, your nutrients get absorbed first to the surface of the bugs before they move and diffuse inside the bug itself. What this does with a large surface area is by putting in a very small amount of this product. So we typically dose a pound, this is a pound, we would dose about 2 pounds of this material for every 1 million gallons a day of capacity. So this is all that would go into a 1 MGD plant on a daily basis. And this is sufficient because of that very large surface area to ensure that we're able to cycle nutrients to the microbes that are embedded within the particles. They feed on that, they begin to generate and replicate, and then they are diffused outwards into your wastewater treatment process. So this is just like a nursery. a small amount of material goes into the plant, and using that, you're actually able to ensure that you have a healthy consortium of microbes that will allow you to do the treatment you want to do. In terms of applications, we have a broad range of applications. So solids reduction, improved sludge characteristics, typically within about a couple of weeks of using the product. One of the immediate things you begin to see is improved sludge settling characteristics. Gives you the type of microbes that actually settles better, which can translate into things like improved capacity in clarifiers, better effluent quality, and those types of advantages. And then one of the things we've been doing over the last, we've been doing this for an extended period, more recently within wastewater, is helping to increase biogas generation. So in this particular case, we helped this plant reduce solids, but this was a small plant that didn't have much use for its solids beyond just treating those solids and sending it to a landfill. They were paying for it. Well, if you're a larger plant and you have an anaerobic digester, then you certainly don't want to reduce the solids that are feeding your digester. You want your wires. You want all your wires to go to the digester. But if you could boost what's going on in an existing digester, if you could increase it by 20 to 30% by doing nothing other than just putting microbes in there that can enhance the breakdown of wires and primary sludge, improve the fermentation step, and enhance the final step in the digester, which is methane generation, methanogenesis, you would do that. And what our microbes allow you to do is to actually do that precisely. So we have a range of products. All our products have this porous media as the base. So they all have this porous media as the platform. And then the only difference between the products is actually in the exact composition of the microbes that we put inside of it. So if we're trying to improve things in the aerated portion of the plant, we would mostly have aerobic and a few facultative microbes. If we're trying to enhance things in the digester, we would have microbes that enhance fermentation, the fermentation step and the hydrolysis step. And then we would, in some cases, also have microbes that enhance methane generation. So methanogens that are responsible for that final step of generating methane. So a broad range of applications. We do a lot of work both on the municipal side and the industrial side. In fact, we started out a lot of our work in the oil and gas industry doing a lot of bioremediation of oil spills. And we also do a lot of work on the animal side. So many of the swine farms and many of the cattle farms, we actually use our product to help them significantly manage fecal matter and sludge and manure within their lagoon systems. So I suppose I'll stop now and take some questions from anyone that might be interested in learning a bit more about what we do.
Is this something you do once a month, once a year?
So that's a great question. When we're applying this to the aerobic zone in a plant, we're dosing daily. And we're dosing at a rate of 2 pounds of the material for every 1 million gallons a day of capacity. If we're dosing into a digester, we would dose once within the HRT of the digester. So if a digester has a 20-day hydraulic retention time, we would typically dose once within that 20-day cycle. All that we want is to ensure that we have some of these materials present within the treatment system over the sludge age or over the sludge age, essentially.